Woo! Moon's origin, astronomy lesson 3.1. So first, let's take a look here. So we're looking at the moon. The moon is our closest neighbor in space, so this is kind of like a quick tour from here. So what is the moon? The moon is Earth's only natural satellite. It's the only thing we got. We have many artificial satellites, but as far as natural, the moon is primo uno, number one. One of many moons that are in our solar system, and like I said, only moon of Earth. What else do we got? So, where did it come from? There are a few competing hypotheses on how the moon developed. I'm going to go through some of the top ones, and then I'm going to go through the one that's mostly accepted by the scientific community. So the first one is known as the capture method. So this basically states that sometime in Earth's early history, there is a large asteroid known as the moon, and it flew by Earth, and the Earth reached out and grabbed it and said, hey, be my friend, and you can be the moon. And the moon was like, sweet, we can be friends, and we're going to hang out, and I'm just going to, revolve around you. But that kind of lost favor because there was no way for the Earth really to capture this. The moon, Earth mass size is not that, is great, but not great enough to do that. And it probably would have led to the collision of the moon into the Earth, if anything. Okay, so scratch the capture method. What else we got? So fission. All right, this is a cool idea. Let's take a look at this, how this works. So Earth, when it was young, was spinning so rapidly that it actually expelled a piece of mass, which would explain why the Earth and the moon have similar rotations and revolution. It also could explain that, some of the makeup of where the moon might have come from. So why did this lose favor? So big thing here is we went to the moon. Hey, look at that. Sorry, spoiler alert. And we took these rock samples, and we found out that the moon is more like the Earth's crust than it would be like our core. So the material of the Earth moon doesn't support this. All right, cool. Scratch that out. Fission. Out of here. What else we got? All right, this is a cool one. So basically, picture this. The Earth-Moon formed together, but separately, as a double system. So as the primordial Earth and primordial Moon, as they were rotated, they kind of were able to clump together and form these two separating bodies. However, it doesn't necessarily explain the angular momentum of the Earth-Moon and their size differences. In other words, why wouldn't they have just been the same size if they were forming together? They're so close to each other that they should be relatively the same. So we'll have to cross this one out too. So I just gave you a bunch of theories, or hypotheses, not theories, about what's going on with our moon. So what do scientists believe? So most scientists have come across this and have said, hey, this makes the most sense. Now, in next year, 10 years, 20 years, they might revise this. It's okay for this to happen. It's normal. Just because we find new evidence doesn't mean that all the other stuff goes out the window. We're just trying to make it better. Okay, we're just trying to, find everything and make everyone happy. And, well, maybe not happy, but we want to make all the evidence happy and say, hey, evidence, we didn't forget about you. So, giant impact hypothesis. So, basically how this goes is we have a large object, roughly the size of Mars. And at some point in Earth's early history, while Earth was still molten, it, bam, smashed into the Earth. And it was able to kind of jettison out a piece of the Earth and this asteroid that impacted it. And eventually, once the moon and Earth kind of continued to rotate, was able to clump back together, we lost whatever rings we would have had, and it formed the moon. So, why do we believe this? Let's take a look. So we have a few pieces of evidence that we can look at here. Evidence number one. Earth's spin and the moon's orbit have very similar orientation. So they are very similar. They're very close. They look almost the same. I don't know any other ways to say that. All right, then. Let's go on to two. Like I said, we've been to the moon. Sorry, conspiracy theorists. Let's say what we did for the sake of argument and evidence. We had these moon samples, and again, they indicated the moon's surface was once molten, very similar to Earth's. The moon, through the study of radio waves and studying X-rays, thank you USSR, the moon has a relatively small iron core. That's cool. The moon also has a lower density than Earth, similar to how Earth's crust has different densities. Additional evidence, we've seen collisions like this happen in other star systems that result in similar debris disks. So we've seen it before. Cool. This is also how we kind of think that some of our solar system might have developed. Cool. The last one is a little bit more technical, but basically the isotope ratio of lunar and terrestrial rocks, so rocks here on Earth, are identical. So they're giving off a similar origin. We're made up of, we came about the same way. So some very strong pieces of evidence. Again, with SpaceX and this commercial going to the moon and privatization, maybe we'll find more. Maybe this will drive more and find some more information out. But for right now, this is what we got. All right, thank you very much, and I will talk to you in the next section.